Welcome back to the Deep Dive. This is the place where we really try to get under the hood of some complex topics shaping our world. And today, we've got an electrifying one for you, literally. We're diving into the future of fast EV charging. Think about it. Pulling up, plugging in, and being ready to go almost as fast as filling a gas tank. That's the future we're exploring. We pulled together some great sources for you reports looking at infrastructure in Europe, some deep scientific papers, articles comparing technologies, even a risk analysis. Our mission today, to give you, our listener, a really clear, exciting, and thorough picture of where fast charging is now, where it's headed, the tech involved, the hurdles, and, the smart solutions popping up.
It's definitely a hot topic. You see the EVs on the road, the excitement's building, but making that whole experience smooth, convenient, that's the key, isn't it? And fast, reliable charging. It's right at the heart of that. Our sources today really do paint a picture of, amazing progress, but also, frankly, a lot of work still needed.
Right. Let's jump straight in. Why the big push? The need for speed. We all know about range anxiety, the worry about long charge times. It puts people off EVs. But things are changing fast. China seems to be really pushing things forward. I saw this BBC piece mentioning a battery swap station. Yeah. Slogan was, battery swap stations are equivalent to gas stations for electric vehicles. It kind of says it all, doesn't it?
It really does. Captures that end goal perfectly. Getting energy into the car quickly, easily, just like we're used to. And yeah, battery swapping is one approach the BBC looked at. You drive in, swap your empty battery for a full one, boom, done in minutes. Sounds great on paper.
It does, but there's a catch for most regular cars, right? Compatibility. Not every car is built for it. But the article did say it's gaining ground for commercial use in China. Taxis, delivery vans, that sort of thing. Why them specifically?
Well, think about it. Commercial fleets often have predictable routes, centralized management. It just makes the logistics easier. Keeping track of charged batteries, scheduling swaps. It's much more manageable than for millions of individual drivers doing their own thing. Makes sense for, say, city delivery vans.
Okay, yeah, that clicks. So swapping has its place, but the other big push is just making the charging itself faster, much faster. And sources point to huge leaps there, especially China again, rolling out these high-voltage systems, 800 volts, even higher, supposedly becoming mainstream next year, 2025.
Yeah, the speed of development from companies like BYD, XPeng Neo, it's pretty staggering. They're talking supercharging tech that gets you from 10% to 80% in, around 15 minutes? That's a massive difference, really close to the gap with refueling times.
But then BYD dropped that announcement recently, aiming for 400 kilometers, about 250 miles of range in just 5 minutes. And planning like 4,000 of these flash charging stations, that's twice as fast as Tesla's superchargers. I mean, that's just mind-blowing. What does that do for long trips?
It's certainly a bold claim. And look, if they can deliver that reliably at scale, yes, it could absolutely be a game changer. It hits that core anxiety about charging Times Square on, could make range anxiety a non-issue for a lot more people.
So we're seeing these two paths emerge, swapping for certain niches and this ultra-fast charging for everyone else. The BBC called it a two-horse race. Let's stick with swapping for a minute. Speed is the big pro. What are the cons the sources highlight?
Well, the BBC piece brings up a few key things. Number one, you need charged batteries available when you show up. Reliability is crucial. They shared an anecdote. A Neo owner nearly missed a meeting because the swap station they drove to out in the suburbs just didn't have any charged batteries ready. That's a problem.
Right, so the swap might be quick, but if there's no battery or a queue, you're still waiting.
Exactly. And then there's the business side for passenger cars. It's tricky. The BBC notes it's clearer for commercial use in China, high mileage, predictable routes. Maybe separating battery costs from the car purchase helps too, like a subscription.
And I guess the big government subsidies in China for swapping schemes make a difference too.
Oh, absolutely. Huge factor. Government backing, pilot programs, it signals a real push. But even then, the sources give some real-world flavor. A Beijing taxi driver had both options, charging and swapping. Preferred charging because swapping cost more. Apparently, they'd even avoid swapping if they had a decent battery. That tells you something, doesn't it?
It really does. Cost matters. And the article mentioned drivers arguing over poorly performing batteries at swap stations. Oof.
Yeah, paints a picture, doesn't it? Speed is great, but there are still wrinkles in efficiency, user satisfaction. Although the BBC does point out one clear win for swapping right now. Heavy-duty trucks. Huge batteries. Swapping is still way faster than even the best charging tech for those bigwigs.
Okay, so swapping seems strong for specific uses, commercial fleets, maybe big trucks. But for most of us, ultra-fast charging looks like the main event. Let's shift to Europe then. The AWS Charging Report 2025 focuses there, especially Germany and the Netherlands. First off, they categorize chargers by speed. Can you break that down?
Sure. The AWS report lays it out simply. Slow is up to 7.4 kilowatts, average is 7.4 up to 22 kilowatts. Then you got fast, which is 22 up to 150 kilowatts. And ultra fast is anything 150 kilowatts and above. They sometimes use high power for 100 kilowatts plus. It helps frame the discussion.
And the report sounds an alarm bell, doesn't it? Europe needs way more public chargers, like yesterday, to meet EV demand and climate goals. The numbers are big.
There really are. Europe needs 8.8 million public charge points by 2030. That means installing 1.2 million a year. That's over 23,000 installations every single week. And in 2024, they managed 950,000 total. So quite a shortfall, a big gap to close urgently.
And it's not just sticking chargers in the ground, is it? There's this huge bottleneck. The grid itself, especially in crowded places like the Netherlands, Germany, Belgium, Italy, the CPOs, the charge point operators are hitting limits.
Yes, this is a massive challenge. The AWS report says getting grid extensions approved and built can take 2 to 5 years in these areas. Sometimes the local grid operators just say no, the capacity isn't there, so CPOs are stuck trying to squeeze more out of the power they already have access to.
Wow, 2 to 5 years. That's a long time. So how do they cope? The report mentions virtual grid expansion using batteries and solar. Okay, unpack that for us. Sounds clever.
It is pretty clever. Rahul Banu from Eon Drive explains it in the report. Basically, instead of waiting years for the grid operator, you build your own local power buffer. You install big battery storage systems on site, maybe add some solar panels. This lets you increase charging capacity without that big, slow grid upgrade.
Ah, so the battery stores energy, maybe cheap off-peak grid power or solar power, and then feeds it to the chargers when demand is high, taking pressure off the main grid.
Precisely. And they mentioned software too, like Xeon, an energy management system. It optimizes everything. Does things like dynamic load management, juggling power between cars and peak shaving, so you don't draw too much power from the grid all at once and trigger limits. Crucial in places like the Netherlands.
Sounds like smart engineering to work around the limitations. The AWS report also stresses user-friendliness. Makes sense. What specifically?
Yeah, you need it to be easy. The report highlights things like simple digital payments, clear pricing, no nasty surprises, and making sure stations work for any EV brand. If charging is a hassle, people just won't switch to EVs. Simple as that.
Totally agree. Okay, let's talk about drivers. What do EV owners actually want? The AWS survey dug into this. Convenience, cost, and speed seem to be the big three.
That's the trifecta, yeah. Most driving is short city stuff, but people do take longer trips, weekend drives, and for those, most drivers, like 70%, actually plan their charging slots ahead of time. Shows you still need that reliable public network.
And interestingly, price per kilowatt hour is a huge factor for fast charging. Over half said it was important. So speed is great, but people are watching the cost.
Definitely. And there's brand loyalty too. Over half prefer certain charging networks, some even drive further to use them. Oh, and amenities matter. Toilets, maybe a coffee shop nearby. Important for over half the people surveyed. Kind of like a regular service station stop, really.
It really is. The report also looked at where people charge. Home is still number one, but public charging is significant, 32% of all sessions.
Right. Home charging is convenient if you have it. But public charging, especially fast charging, is vital for long distances and for people in cities without driveways or garages. And the survey says most public sessions are around 20-30 minutes long, fits with current fast charger capabilities.
And priorities change depending on where you are, right? Convenience at home, speed at DC fast chargers, cost maybe at work.
Exactly. Convenience for home and slower AC public chargers. Speed is king for those DC fast chargers on the highway. Affordability and ease matter if you can charge at work. But the one thing that always matters, no matter where you are, is the battery level, the state of charge, or SUC. That's the universal trigger for deciding when to charge. The survey also picked up on this trend of smart multi-asset homes. People with solar panels are way more likely to also have a home charger, battery storage, and use smart tools to manage it all and save money.
Yeah, shows how it's all connecting renewables, EVs, smart homes. Okay, let's get technical. How do we get these faster speeds? The IJSRM paper traces the evolution.
Yeah, that paper gives a good overview. We started with basic level 1 and 2 AC charging slower, using the car's onboard converter. Then came DC fast charging, DCFC. That bypasses the car's converter, sends DC power straight to the battery, much faster. Start around 150 kilowatts, now we're talking ultra fast, over 350 kilowatts.
And there's that clear link the paper shows. More power equals less time. Like 50 kilowatts might take 40 minutes to 80%, but 350 kilowatts could do it in, 68 minutes? Huge difference.
It is. The paper touches on the physics, too. Power equals voltage times current, PEDXXI. Ultrafast uses high voltage, maybe up to 1,000 volts, and high current over 350 amps. That combo delivers the power, but managing the heat and safety becomes a big engineering challenge.
Right. The paper mentions things like cooling for lower currents, but liquid cooling needed above 350 amps because of the heat. It also covers communication protocols so the car and charger talk properly, grid connections. But it also raises the trade-off, right? Pushing power that fast.
Yeah.
What about the battery's health?
That's a really critical point the IGSRM paper covers. Faster charging means more heat, which batteries don't love. There's also a risk of lithium plating on the anode at really high rates, which can degrade capacity over time and slightly lower efficiency, more energy lost as heat. So advanced thermal management inside the battery pack is absolutely essential to handle ultra-fast charging without damaging the battery too quickly.
So the cars themselves need sophisticated cooling and battery management systems. The paper also notes who's leading the charge globally: China, Norway, Germany, networks like Tesla's Superchargers, Ionity. And looking ahead, it mentions solid-state batteries as maybe the next big thing.
Indeed. Solid state holds promise for better safety, maybe higher energy density, potentially allowing even faster, more efficient charging down the line. Still development work needed there, though.
Okay, back to the infrastructure. Cyber switching really hammers home that you need robust systems, grid upgrades, heavy-duty hardware, cooling. You can't just drop an ultra-fast charger anywhere.
Exactly right. And the Innovation News Network talks about that challenge. Do stations even have enough power capacity? But they mention an interesting study finding. Doubling charger power doesn't necessarily double the peak load on the station. Why? Because the charging sessions are shorter. So cars come and go quicker, less overlap. It suggests maybe we can deploy more ultra-fast chargers than we first thought without completely crashing the grid.
That's actually quite encouraging. The article also looks at solutions for managing power, like dynamic weighting strategies or using on-site energy storage again.
Right, dynamic weighting just means maybe staggering when cars start charging slightly to smooth out the peaks. And energy storage, like those batteries we talked about. Yeah, it costs more upfront than just a bigger transformer, but it avoids those long waits for grid upgrades and gives you more flexibility on location. The article does say the main costs for upgrades are usually the chargers themselves and the distribution transformers needed.
And finally, but maybe most importantly, safety. The PCIC Energy paper looks at risk management, especially putting chargers near gas stations or in enclosed parking garages.
Yes, very important focus. That paper highlights the unique risks of lithium-ion battery fires. They can be very hard to put out, burn for days sometimes, and release nasty gases. They use this bow tie model to map it out. Causes, prevention, the event itself, mitigation, consequences. A structured way to think about risk.
And the main risks are electrocution, or a fire from the battery failing, caused by things like faulty equipment, operating outside limits, or just ignition sources. Consequences are obviously severe injury, death, property damage, losing business.
Absolutely. So the paper details preventative steps, good equipment, proper grounding, safety rules, electrical protection, and mitigation steps, secondary protection, preventing ignition sources nearby, having solid emergency plans. It specifically calls out enclosed spaces like underground parking or multi-story garages. Big challenges there for evacuation and firefighting if something does go wrong.
It's crystal clear that safety and managing these risks have to be top priority as this infrastructure rolled out everywhere. You need public trust.
You absolutely do. Understanding the risks, building in robust safety from the start, it's non-negotiable for making fast EV charging successful and widely accepted.
Okay, so wrapping up this deep dive. It's clear the future of fast EV charging is moving incredibly quickly. We've seen amazing strides in ultra-fast charging speed, especially led by China. Battery swapping has its place, particularly in commercial fleets. Europe's got big infrastructure hurdles with the grid, but clever solutions like virtual expansion are emerging. We learned drivers want that mix of convenience, cost, and speed. And the technology itself is evolving rapidly, bringing huge benefits, but also needing careful management for battery health and, crucially, safety. Integrating it all safely and reliably is the key.
Absolutely. Making that charging experience fast, easy, reliable, and safe. That's really what the whole transition hinges on. The sources show challenges remain, definitely, but the innovation and the drive toward electrification, that momentum feels pretty unstoppable right now.
And on that electrifying note, as the currents of innovation surge forward, powering a greener tomorrow, remember that knowledge is the spark that ignites change. If this deep dive into the fast-paced world of EV charging has sparked your curiosity, if you've connected with these insights, then channel your energy into the All Sorts podcast community. Like a high-voltage connection, your thumbs up on YouTube amplifies our signal, sharing this knowledge with others eager to plug into the future. Subscribe to the All Sorts podcast on YouTube and become a vital conductor in our network of learners. Just as a fully charged battery propels you on your journey, our extensive back catalog of All Sorts podcast deep dives is brimming with explorations just waiting to power your understanding of a diverse range of topics. Explore our archive and discover new currents of thought. And for real-time connections and sparks of insight, follow the All Sorts podcast on X, Instagram, and Threads. Let's keep the conversation flowing, sharing ideas, and charging forward together. Thank you for joining this illuminating journey on the deep dive. Here's something to think about. As charging speeds keep accelerating and that infrastructure grows, how does it fundamentally change how we think about getting around, about using energy? What new possibilities and maybe new challenges arise when refueling takes just minutes, not hours? Keep that charged until next time.